Good morning, second grade. So today in math, we're going to be talking about intersecting and perpendicular lines, okay, or line segments. Now, we've talked about parallel lines and line segments, and we know that parallel simply means side by side and never touching. So like these two line segments are side by side and they don't touch, okay? Even if they were lines, which means lines have the arrows at the end, meaning they never stop. Even if these lines kept going, they would never touch. They'd be side by side. So the top are parallel. They're side by side. My next side of line segments, these are what we consider perpendicular line segments. Okay, notice about the perpendicular, they cross at kind of like a perfect plus sign. Okay, because remember we were talking about right angles. Right angles are perfect L's, right? Well, perpendicular line segments, they cross and they make right angles. So if I were to put this in there, you would see that it would be a perfect little L. Same for over here. All of them are perfect L's. So it's kind of like like a perfect plus sign, right? So these are perpendicular. So if they make right angles when they cross, they are considered perpendicular. But not all line segments, when they cross, make perfect right angles. Some of them cross, okay, without making. Like this is obtuse, it's real large, and then you have the little cute ones here. So this is called an intersecting line segments, okay, because they cross, but they do not make perfect L's, right angles there, okay? So intersecting, and what helps me remember that is I think about an intersections. When you come in a road, they cross over other roads. It may help with where the road crosses over to another road, right? So they intersect, they cross. Interstates, when you're on the interstate, you cross into another state, right? So entering into another, right? So intersecting line segments. So again, parallel, side by side, never touching. Perpendicular, crossing but making perfect right angles. And then intersecting lines, they cross but they do not make perfect right angles. All right, so you have a sheet that looks like this, okay, and we are going to make some perpendicular line segments. And so what you would do, you could take a ruler or you could just draw them. That's fine, you don't have to use a ruler, okay? And mine's not going to be perfectly great anyways because they're going to have the ruler here. And you can I'm going to make a set of perpendicular lines. So that is a perpendicular line. Okay, they cross, they make perfect L's. Now there are letters that also have perpendicular line segments in them. Can you think of one? Okay, I can think of one particular that I think about, and I think about the letter T. And I'm just going to draw it with my hand free draw, the letter T. Okay, the letter T, it crosses right here, and when it crosses, it makes right angles. So therefore, the letter T has a perpendicular line segment. Okay. Now there are some letters that have only intersecting line segments. For example, I'm just going to draw one over to the side since the sheet says perpendicular. We're focusing on that. If you look at the letter V, sorry, that's awful. The letter V, and that's not really a good V. So I'm going to change that. Look at the letter V. It's actually, they're crossing, but they're crossing kind of right here. Even the letter X, because when I cross it, it makes the letter X. They cross, but they're small. They're not making perfect L's. So therefore, that is not, it would be considered intersecting line segment. It's not a perpendicular line segment. So I'm going to give you one more letter, and then I want you to see if you can come up with a letter that has perpendicular line segments. For example, I have the letter E. The letter E has perpendicular line segments. They cross here, they cross here, and they cross here, and so they make a perfect right angle here. They also have parallel lines, which from here to here, but they also have perpendicular. So this line crossing with this line is perpendicular. This line segment crossing with this one's perpendicular. This line segment with this one is perpendicular. So I want you to send me a picture of you creating a letter that has perpendicular line segments in it. So ones that cross that make perfect right angles. Okay, so now now we have our... Alright, so now we're going to be doing our sheet, our guided practice. Now again, I said yesterday that we're going to be speeding up a little bit so that we can get to a good stopping point. Let's see if I can move it from the sun. The first thing we're going to do is draw a 7-centimeter line segment for our name. That's my inches. Here's my centimeters. Alright, start here, go all the way to the 7. Again, it's really hard to hold the phone and draw that. But anyways, there's my 7-centimeter line segment. Okay, I'm going to add my name. And today's date is April the 28th. And guess what, guys? There's only 2 more days left in April. Whoa. So Friday will be May 1st. Okay. And then I have to measure my date line. So I'm taking my ruler. It wants it in centimeters. I start at the 0 point and it goes all the way to here. So it's 5 centimeters long. Okay. Now, number 1. It says pencils are sold in packages of 3. Okay, they're packages of 3. Mrs. Conlon bought 7 packages of pencils. Draw a picture to show the packages of pencils. So she bought 7 packages. So I'm going to draw 7 packages. So 1, 2, 3, 4, 5, 6, 7. So there's my 7 packages. And each pack has how many in it? That's right, 3. So I'm going to draw 3 in each. 1, 2, 3. If you want to draw beautiful pencils, that's, more than welcome. But I'm just drawing dots. So I drew 7 packages. And each package is going to have 3 in it. Okay. Now, what kind of story problem is this? I like to draw it out and then decide what kind of problem it is. But you could answer that first if you'd like. What time of problem? It's in equal groups. Very good. Okay, so now it says how many pencils did she buy? So she had 7 times 3, and that's 3 7s. So you could say 7 plus 7 plus 7. Or you could sit here and you could count those. Okay, so 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. 21 pencils. Okay, so the answer is 21 pencils. Okay, now we have number 2. It says to circle the perpendicular line segment. So remember, perpendicular means they cross, making perfect right angles. Let's look at the first one. What do you notice about these? They're side by side and they do not touch. Are those perpendicular? No, those are parallel. They're side by side and they do not touch. So that is not perpendicular. Let's look at the next one. All right, they cross, so they're not parallel, but let's see if they make perfect right angles. Sure enough, they do. So that is perpendicular. So I'm going to circle that one. Okay. Now it says segments, so there's got to be more. Maybe there could be more than one. So let's see. Let's look at this one. They cross, but are they perfect L's? They're sideways, so it's kind of hard to say. So let's see. Sure enough, they are perfect right angles, so that is perpendicular. So that looks like the letter X. So if you drew your X like this, they would have perpendicular. But most of us, when we draw the letter X, we kind of go a little bit closer together and don't make those. So that's why earlier when I said the X didn't really have any perpendicular line, because this is really just look more like a times table. Okay, so these two are perpendicular. They cross, and if you were to put an edge in there, you could see that they're perfect right angles. Okay, so those two are perpendicular. All right, what about this one? They cross, but let's see if those are perfect L's. Let's see, perfect right angles. No, that's way bigger. So this is not. What do we call ones that cross that do not make right angles? We call them what? intersecting. So these are intersecting. So these are not perpendicular. What about this one? It looks to be perpendicular, but let's double check. I put my edge in there. Sure enough, it is. So I'm going to circle that one. So there are 3 here that are perpendicular. They cross, making right angles. Okay, now the next one. It says how many small squares are in the rectangle? Because I'm trying to find the area, which is the distance on the inside of the shape. How much space is on the inside here? So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 square units. So that is an 8 square unit rectangle. And it says to color 1 square. So I'm going to color in one of these squares. Ooh, there we go. Done. That was easy, right? And then it says, what fractional part of the rectangle is colored? Well, I've already counted them, and I know that there's 8, and I colored one of those 8. So 1/8 are shaded or colored. All right, number 4. It's been a while since we've done a lot of rounding together. So let's round. The number 78, which is the closest 10 that it's closest to. On a number line, the number 78 falls between what 2 numbers? Right now it's in the 70, so it falls between 70 and 80. Remember, we look to our right. Remember the rules. Okay, remember our rule? That's right. 4 or less, let it rest. 5 or more, let it soar. So it is 5 or more, so we're letting it soar. So is it going to be 70 or 80? That's right, it's going to be 80. So we're letting it soar. We're going up. So it rounds to 80. All right, my next one. It's currently in the 1/10s, which is 10. So it's between 10 and 20, right? Between 10 and 20. And I know that I look to my right. Remember my rule. If it's 4 or less, let it rest. If it's 5 or more, let it soar, right? So we are letting it, it's 4 or less, so we are letting it rest. So it should be 10. All right, now 25. Okay, it's currently in the 20s, so it's between 20 and 30. Okay, I look to my right, it's a 5. Okay, remember my rule again, 4 or less, let it rest. 5 or more, let it soar. So that is a 5, so it's 5 or more, so I'm going to let it soar. So it's going to be 30. Okay, here's my next one, and I brought some shapes to help out with this one. It says circle the geometric solids that have at least one vertex. And don't forget, the vertex is, so the flat side is your face. You've got your edges, which is here, and then your vertex is the point, which is here. Okay, so let's look at a pyramid. So here's a pyramid. Does it have a vertex? Does it have a point? It has to have at least one, does it? Yes, it has one at the very top, right? That's a point. It has a vertex here. It has a vertex here, 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 and here. So it has 4 on the bottom and 1 on top. So it does have vertex. So that does have a vertex, and I just drew it myself, but it's okay. So I'm going to draw the pyramids because that's a yes. But it said all the geometric solids, so it's going to be more than one. So the pyramid does. And also the pyramid has faces, which is the flat side, and it also has edges. Okay, so now we also have the cylinder. So let's pull out my cylinder. Okay, it's got a rounded side, and it's got 2 faces. It's got a flat side here and a flat side here. It doesn't, does it have any vertexes? That doesn't, no, doesn't have a point, does it? So no. So not that one. All right, a cone. Let's see, I got a cone in here somewhere. There we go. Okay, so it's got a rounded side here. It's got a face here, which is the flat side. Okay, and it's got a, what's this at the very top? That's right, a vertex. So it has at least one vertex. So a cone does have at least one, so we're going to circle it. Okay. And then we have the sphere. This is our sphere. Does it have anything? No, it doesn't. It's just all smooth and round, so it does not have anything. And then we have the cube. Does it have vertexes? Yes, it does. It has 4 on this side and then 4 on this side. It says 8 altogether. It says 8 vertexes. So it does have vertexes. So I'm going to circle that as well. Okay. All right, and then the bottom. We're going to subtract first. Okay, so we're going to say that I could draw a line to separate if you want to, but you don't have to. I could say 2 minus 8. Remember the rule. If the number is smaller on top, you cannot do it. So we got to go next door. I'm going to borrow a 10 from the 6. I'm going to take one from the 6. If I take one, it becomes a 5. That makes this 2 become a, so I brought 10 over, that 2 becomes a 12. 12 minus 8. So put 8 in your head and go up to 12. So 8, 9, 10, 11, 12. So 1, 2, 3, 4. So the answer is 4. Okay, to put 3 in your head and go up to 5, because 5 minus 3. So 3, 4, 5. So 1, 2. So it is 2. So 24. All right, now we're adding here, and we're adding 3. And if you need to draw your line to help you out, you may. Okay. 8 plus 7 is what? This is your doubles plus 1. So 7 plus 7 is 14. Plus 1 more is 15. So this equals 15. If you need to cross it out so you're not confused, you can. 15 plus 5 is 20. Put your 0. You have 0 ones and carry your 2 to your tens place. 2 plus 6 is, so 6, 7, 8. So this is 8. If you need to cross it out and put it there, you can. 8, 9, 10, 11, 12, 13. So that'd be 13. And there's nowhere to carry, so I can put 13 here. So 130 would be my answer there. All right. Dealing with money. All right. So 3 plus 8 is what? So 8, 9, 10, 11. Put down my 1. Carry my 1 to my tens place. 9 plus 1 is 10. Plus 7 more is 17. So I'm going to put down my 7. And I'm going to carry my 1 over. Now you can bring down this decimal. Go ahead and bring that down. Decimal plus decimal is, well, decimal. All right. 1 plus 2 is 3. Plus 3 more is 6. And then I'm going to bring down my money sign. Now notice the first 2 are not money, but this one is. Some of you get in the habit, you think, well, I just always put money signs, or I just never do it. Okay, got to pay attention to whether it is money or not. So this is $6.71. Okay, and then my last one, 8 times 10. So 8 times 1 is 8, and then add that 0, be 80. You can skip counting by tens 8 times. 3 times 1 is 3, and then add those 2 zeros. So 3 hundreds is, well, 300, right? 8 tens would be 8. All right, if you have any questions, feel free to message me. All right, love you guys. Bye.